Hi, this is a recorded lecture for the IB-DP Design Technology, topic C1.2, Inclusive Design, and this is Design in Context. From the IB, inclusive design includes products that address the needs of the widest possible audience, regardless of their age or ability, and focuses on designing universally acceptable products for all users. You must be able to discuss how inclusive design requires designing universally accessible products for all users, including those with physical, sensory, or cognitive impairment. So, inclusive design or universal design, this creates products, services, environments, and experiences that consider diversity, are accessible and usable by the widest range of people, regardless of age, ability, or other characteristics, without the need for adaptation or specialized design. You should actually watch this video. It'll give you some understanding of inclusive design. When we talk about inclusive design, we need to think about physical accessibility. The one thing that I would say about inclusive design is the idea here is that you're including everybody in the design. And quite often you'll have a design which will make it so that it's more accessible for not just people who are in the extremes, or people who are disabled. It might be more accessible for people who are also physically able. So, for instance, a ramp is an excellent example of this. Of course, a ramp is great for a wheelchair. A wheelchair cannot navigate these stairs, but also it's great when you have a baby and you have a baby in a baby carriage. You can take the baby up the ramp, or maybe you have a cart that you need to roll up the ramp, or a bicycle. Having a ramp makes it accessible for everybody, not just for people in a wheelchair. The same can be said for an adjustable desk. This can be great for somebody who's tall. It can be great for someone who's shorter. It can be great for somebody who is paralyzed in a wheelchair. It's great for everybody. And so inclusive design is really about that. It's making the environment so that everyone can use it, no matter who they are. Another example of this can be sensory accessibility. And again, these are great for people who are also not, say, hearing impaired. So for instance, if you're hearing impaired, you're not going to hear a smoke alarm. So you may need a visual signal, but that's not a terrible thing for everybody to have a visual and auditory signal. For instance, what if you're wearing headphones or earphones and can't hear the smoke alarm or some sort of warning signal? Having a visual indicator can also be helpful. And the same for if you have vision impaired, having some sort of other haptic or auditory way of alerting you can also help. These are products that are actually for hearing impaired and vision impaired, but are good for everybody because this has haptic capabilities and this has visual capabilities. This is a few examples of people that might need different cognitive accessibility, and these are examples of things that are really mapped well. And so these are inclusive designs. So somebody may not understand that these different knobs go with different burners. In fact, I don't know which burner this knob goes with, but here it's mapped well, and I can see that, oh, okay, this one goes here, and this one goes here, and this one goes here, and this one goes here. So someone with some sort of cognitive disability, this would be a better design because it's mapped well and they can understand the correlation of the knobs to the actual burners, compared to this where it's not entirely understandable. This is also an example of a car seat adjustment, and you can see that this is actually the back of the seat and this is the front of the seat, or the actual seat itself. And so this is mapped well to the actual car, and it's much more understandable than other different ways that you can adjust car seats. Inclusive design promotes equality, so it ensures access for everybody. It expands markets, increasing customer bases, and it encourages innovation because great accessibility improves designs for all users. Let's talk about some of the different impairments that people might have that we need to design for. So you might have physical impairments, and those might be mobility limitations like paralysis or muscle weakness, missing appendages, arthritis, or fine motor skill problems. You might have sensory impairment, so that might be vision, hearing, touch, or balance. So this could be partial or full blindness, partial or full hearing loss, numbness or reduced sensitivity, so that would be for like touch, and then the vestibular system, so maybe somebody has vertigo. You might have cognitive impairment for a lot of different reasons. So this would be mental functionings. So for instance, you might have a memory disorder, like an older person might have dementia. You might have attention disorders like ADHD. You might have learning disabilities like dyslexia. If all the signage in, for instance, emergency exits are all in words, maybe somebody with dyslexia might not be able to read those words. So it's better to have sort of a visual explanation of exit signs. You might have intellectual disabilities like Down syndrome, or somebody might have a brain injury. I think you should watch a couple of these videos here. These are great examples of some inclusive designs. There are some limits to inclusive design. So inclusive design is not always possible, and you need to be able to discuss how the average person correlates to the 50th percentile, and this is adults, children, and how it's not always appropriate to design for the average person. So first of all, we talked about this in ergonomics. Percentile is a term that describes how a data point compares to all data in that set, and it's divided into 100 equal parts. The 5th percentile is on the extreme small side of the population, and so basically it would mean that 95% of the population is, say, in this case, taller than the 5th percentile. The 50th percentile is right in the middle of the distribution, so half the population is above and half the population is below. The 95th percentile is on the extreme large size of the population, and in that case, only 5% of the population would be above the 95th percentile in the distribution. And these are just height distributions for men and women. We might think of things like car seat design. So, and this is one of these limits of inclusive design. You can't always have it for everyone. So a very small adult might struggle to reach the pedals if the seat has limited adjustment. So if you think of designing for the fifth percentile, even that might be too far away from the pedals for somebody who is below the 5th percentile. The 50th percentile, the median-sized adult for whom the standard seat is designed, that would be who you would design the car seat for. If you're in the 95th percentile or above, so a tall or large frame person who may feel cramped without adjustable seat positioning. So if we think of car seat design, you're going to want to design it so that it's adjustable between the 5th and 95th percentile. But if you're below the 5th percentile or above the 95th percentile, even that adjustability might not be enough for you. Door handles are a good example too. So you might think of the 5th percentile. So these are small individuals such as children or shorter adults. They may struggle to reach a high placed handle. They may have difficulty gripping or turning a stiff handle due to low hand strength. Of course, we're probably going to design the handle for the 50th percentile, so that would be the standard handle height. And then the 95th percentile, a person who is very tall might find the handle too low and it would require them to stoop. They may also have a stronger grip, making a small, delicate handle feel awkward. Design for the extremes. The IB wants you to know that designers often use a design for extreme strategy to develop solutions suitable for those with physical, sensory, and cognitive impairment, which are also appropriate for the general population. Students must be able to discuss the advantages of designing for the extremes when designing products for the general population and identify where a design for the extreme strategy has been used. So, design for the extremes is a common design strategy where products are designed or tested to ensure that they function efficiently for those users who represent the 2.5 percentile and the 97.5 percentile. The advantages, of course, is that they're inclusive, so it accommodates children and elderly and those with body sizes that are in the high or low percentiles. It can increase safety, so it can reduce risk for vulnerable users, like, a seatbelt is meant to be adjustable for everybody. So even someone who's young can use that seatbelt. You'll have wider market appeal. So it'll increase that market reach. So if you have sizes that are very big and very small, then you of course can market to a wider range than if you only have a limited number of sizes. There are disadvantages, of course. Cost. So products for the extreme will not sell as readily, and so you'll have to store them, and that can cost a lot of money. It might increase complexity. So adjustability can cause products to have more moving parts and therefore are more difficult to build, and it has just more parts to break. So some methods of the extreme. Doorways are generally built for the 95th percentile, but if you're above that, then you may have struggled to get through a doorway. But you would build a doorway for the high end of the distribution curve. So looking at the 95th percentile and maybe even above that. This is a bit of a joke. This is obviously an old doorway, and this gentleman is very tall. But even in a modern doorway, this gentleman would probably have a hard time getting through a doorway because he is very tall. This is just a classic image. This is Andre the Giant holding a can, and the can is built for the 2.5 percentile, and of course he was not in that percentile. He was quite a large person, so in the 95th, well, probably the 97.5 percentile. So this is an example of a product that's built for the low end of the distribution curve because everybody should be able to hold a can. All right, thank you for watching.